and it has surfactants and chelants. It's very free rinsing product, so that post-rinse step goes on very quickly. It is very effective on burnt-on soils, and it's very tolerant to hard water. Oh, and I should mention here, of course, if you have not seen it, we certainly have this whole trend of organic production, and we are working also very diligently in making our enhanced products be approved for organic production. So once again, we have 3 components of this product. We have the caustic that is going to take care of the organic soils. We have surfactants that are going to help us lift those soils up, and chelating agents that are going to help us with any minerals or just suspension of inorganics. So this was a large dairy processor, and we wanted to look at optimizing the cleaning procedure for the HTSTs. They were their rate limiting step. They were cleaning one, they had another one in production. They wanted to switch one from the other. It was very time consuming to do this. So the pre-trial conditions, they were using 4% caustic solution as their cleaning step, and it was taking them about 5 hours per unit to clean it. We were able to use premium plus alkali at the same concentration, but the improvement here was the time that it took for cleaning. So we were able to liberate a unit in half the time, and so that gave them an increase in production capacity. So they get 1 month of production as a result of the switch from their standard product to premium plus alkali. Again, Flow Foods is where we're using this, but it's ideally suited for high heat processing equipment. The next product is Step Alkali, and this takes, in many customers, it takes quite a mind shift for them. It is one thing to tell them, I'm going to be able to speed up your process by running shorter cycles, or I'm going to be able to speed up your process and let's try to clean at lower temperature, even though that still generates issues. And I think you all have experienced them when you buy cold water detergent, and how many people still use their washer on warm, even though the detergent has been formulated for cold water. But this, I think, is a bigger step when we're telling them, we want you to skip one of the steps in cleaning. We don't want you to run an acid rinse in your cycle. So this is single cycle cleaning. We have good cleaning and rinsing. It's a potassium hydroxide based product. It has a lot of low foaming surfactants that are going to help us lift the soils up. It is excellent for removing burnt soils, and of course, its benefits, as I mentioned, is going to speed up our cleaning and reduce or eliminate the acid cycles. So of course we have water, energy, labor, and chemical savings, but mostly what we're having here is an increase in production time. It is also approved for organic production. So similar situation, we have a caustic, the surfactants, and the chelating agents, just a different formula that allows us to remove minerals from the surface. Different dairy processing plant in the south of the country. It processes, or back then it used to process about 3.5 million pounds of raw milk per week. And the study was concentrated on a 3-stage evaporator and the cream HTST. These were the standard conditions, so they were using between 4 and 5 ounces per gallon of their caustic solution and 2 to 3 ounces per gallon of the acid solution. It was taking them about 4 hours to clean, and they were running production for 20 hours. So once a day, they were running a cleaning cycle. Just examples of what we were able to achieve. So just before the surfaces, it's not that they were dirty surfaces, their system was working well, but we were able to also obtain the same level of cleaning. The importance here, though, was on the savings. So the first savings, because we eliminated that acid step, we eliminated also a rinse step. And so we have a lot of water savings. So we were able to save 94,000 gallons of water for the cream HTST and 440,000 gallons of water for the evaporator. The next thing that we were able to do is that, of course, we're reducing the amount of chemical that is being used. So we were before at 4 to 5 ounces per gallon of their alkaline step. Now we're able to reduce it to 2 to 3, not counting also the fact that we're not doing an acid cycle. But most importantly, we were able to reduce the cleaning time from 4 hours to 2.5 hours. In addition to that, they were able to do longer runs. So instead of cleaning every 20 hours, they were able to go for 30 hours without needing to do a cleaning cycle. What was neat about this plant is that they were getting ready to do some capital investment, because they were short. Their STST was not able to accommodate all the milk that was coming in. And by liberating equipment a lot faster, they didn't have to do that capital investment. So for them in particular was even greater savings than what I'm showing here. A little bit more on the savings. So of course we have an improvement in alkali chemical use, in acid chemical use, and it's not 100% because they still run one acid cycle every couple of weeks. But cleaning time, we have an improvement in cleaning time, a reduction in water use, a reduction in number of CIP cycles per year. We had an increase in production time and production volume. So it's best for us to use it on hot processed surfaces. It doesn't mean that we cannot use it for cold processing surfaces. It's just very good at cleaning burnt on soils. And we find the most effect with these products when we're able to attack the rate limiting step in their cleaning process, liberate the facility faster. Okay, the next product that I want to talk about is one-step acid. So similar situation here, but we are combining the alkaline and acid step with an acid product. So single cycle cleaning. Again, we clean both organic and mineral soils. We're eliminating that chloralkaline cycle. It's very good for, in the presence of hard water. We use it for CIP, so it's a low foaming product. And it's also approved for use in organic applications. Once again, what we're trying to do here is provide the customer with water, energy, time, labor savings. So the idea here is that we are replacing the chlorinated CIP cleaners. We need to find a way to lift the organic molecules from that surface. We rely on a lot of surfactants to be able to do that. The challenge, of course, is that we're doing this through pipes, so we cannot use very high foaming surfactants to be able to do this, otherwise the liquid wouldn't flow through the pipes. This is actually the same dairy processing plant that I was just showing you before, where we did the one-step alkali study, but this one we did it under cold lines. So we did it on the raw tankers, the lines, the silos, and the cream separator. They were seeing about 1 ounce per gallon of caustic and 1.5 to 1 ounce per gallon of acid. And their times vary depending on what they were cleaning, but anything between half an hour to 3.5 hours. So as an example, this is before you clean it. You see a lot of the soil that is present, and after the cleaning, we have very shiny surfaces. So that's before we even get to talk about savings, we need to render the surface as clean as they're used to seeing that surface, if not better. But now the real effect of what we were able to do, the first thing is that we're able not only to eliminate the caustic cycle, but we're able to reduce the dose of acid that we're using, so they're between 0.5 and 1 ounce per gallon. And then the next thing that we're able to do is that in all of the steps, we're able to reduce the cleaning time by half. We have, of course, then water that is saved and energy savings that are associated with the use of one-step acid. So once again, we have the gallons of water that were saved per year after they switch to the one-step acid. And if you combine then the whole thing, they're saving over 1 million gallons of water per year. Again, flowable foods is our best place. We've found this to be very, very effective on liquid egg manufacturing. On bakeries, we've used it very well too. It's worked really well for us on brewery and fermentation tanks. This is the combination of the results that the company had. So after adding one-step alkali and one-step acid, just as the energy consumption analysis. So if we compare, they started using it in around May of 2013. And this is the same point of May in 2014. And so we see reduction in electricity costs. We see a slight increase in production. And we see that the outside temperature was more or less the same. So the energy reduction was not due to changes in outside temperature. Same thing for gas consumption. We see that there is a reduction in gas consumption even though the outside temperature stayed more or less constant. So the savings for the company, about 28% savings. One thing that is important when we do these calculations is that sometimes, because this is not a commodity product, cost of the product can be higher than standard chemicals. But if you take into account all the other savings, then there can be a net savings for the producer. Then the final product that I want to talk about is a new product for DeLaval. We launched the product this year. It's called Acidishine, and it is a built peracetic acid sanitizer. So peracetic acid is an excellent sanitizing product. It has very broad efficacy. It is well accepted within the industry. It has very good environmental profile as well. It breaks down into vinegar and water. People are very comfortable using the product. What we want to do here, though, is combining the acid step or the acid rinse with the sanitizing step. So Acidishine works on two ways. Of course, it has the peracetic acid portion that oxidizes the cells, but it also has the organic acid that helps in some mineral soil removal. So I'll give you some examples on efficacy. The bar that the EPA puts on us for sanitizers is that we're able to achieve at least 5 log reduction of whichever microorganisms we want to make a claim against within 30 seconds to be able to get a 1 minute claim. And this is just an example of some of the microorganisms that we have on the label for Acidishine. We were able to achieve this at fairly low concentrations. So our label lists 75 ppm as your lower dose. If you see over here, this data is actually for 68 ppm. We need to do all of our testing at the lower certifiable limit for the product. So we need to test actually at a lower dose than we're able to claim. And the other thing that is interesting about this product is that we're able to get removal of biofilms. So I'm hoping most of the audience know what a biofilm is, and if you don't, they're cells that are adhere onto a surface, and when the cells adhere to the surface, their entire genetic makeup changes. They start turning on genes that